Knowledge Cube and I'm Ashwin here. Today is an epic video. It is about the world's largest number we know of. This is an amazing video by me and let's get started. Here's the introduction. Ever since you were a kid, you had a fascination in numbers, right? I can guess your question. What is the largest number in the world? But there is no such answer to this question, since you can add 1 to any number. But if you could rephrase that question to what is the largest number we know of, there is an answer. Join me as I travel on a journey to discover the largest number, step by step. Believe me, these numbers are so large that they are uncomputable, really. So let's start from the basics and work our way up. First, the trillions. It has 16 zeros and it would take 32,000 years to count. An example is the $100 trillion note in Zimbabwe due to inflation. Next, we have a quadrillion, which is a 10 to the power of 15. It is the amount of ants on Earth. Next, we have a quintillion, which is the amount of atoms in a single grain of salt. Lastly, we have a octillion, which is a 10 to the power of 26. It is the amount of atoms in the human body. So after the octillion, you have a nonillion, decillion, undecillion, duodecillion, tridecillion, quadridecillion, quindecillion, so on, vigitillion, and again so on. So let's take a huge leap on the number line and reach a 10 to the power of 80, which is the amount of atoms in the whole observable universe. This number is massive and colossal, and do not even try counting it. This is just the beginning. Now, we are going to take a look at the real large numbers. Leaping again, we get to the Google. Hey, isn't this name familiar to Google? The only difference is that Google is a search engine and Google is a number. The number has 100 zeros, which is a 10 to the power of 100. Unfortunately, there is no application to this number as it is larger than the total amount of atoms in the observable universe. Scrolling right on the number line again, we finally reach a magical number which is so large, which is 10 to the power of 85. Let me explain it in this way. We need to take a Planck's length, which is the smallest length according to the law of physics, which is 10 to the power of minus 35, and fill the whole universe with it. The amount of Planck lengths you require is this number. Anything bigger than this number cannot be explained in physical terms. Googolplex, Googolplexian, and Graham's number. Then we have Googolplex, which is the 10 to the power of Google and has the Google zeros in it. There is not enough space in the universe to even write this number. Finally, we reach a Googolplexian, which is the 10 to the power of Googolplexian. Jumping again, we reach to Graham's number, which is invented by the American mathematician Ronald Graham. The G is pictured at the bottom left corner. He explained the number in this theory. In Graham's number, we use arrows instead of a power notation. So 3 arrow 3 gives us 27. So 3 arrow 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 3 is G1. G2 is basically 2 arrows in front, in the middle G1 arrows and 2 arrows in the back. This is the same rule until it reaches G64, which is 3 to the power of 3 to the power of 3 to the power of 3 and then G6 3 arrows and 3 to the power of 3 to the power of 3. This is Graham's number. These numbers are uncomputable, so please bear with me. Counting this number would cause your brain to run into a black hole. The Ryer's number is the world's largest number we know of. Before I explain further, I apologize that I have left many other large numbers like the 3 Skewer's number, and Loder's number. This number was found in a competition held at MIT between Augustine Ryo and Adam Elga. The objective was to explain the world's largest number with mathematical terms. This was Ryo's explanation. The smallest number bigger than any finite number is named by an expression in the language of set theory with the Google symbol on left. I can't explain this because even I cannot understand this. So I have posted a link for Ryo's interview. You can go there and understand it. But you got the answer to your question. Now you're in for a surprise. We are going to look at some infinities. Wait, what? What are infinities? So it's like in the smaller scale we have some infinities, and in the larger scale we have other infinities. Believe me, the infinities are more larger than finite numbers. So let's get started. So we have uncountable infinity, it's elect 1, elect null. That elect null is that n0 right there, but its name is y. Of course, countable infinity does not exist. Infinity goes on forever. Then we have uncountable infinity, which is lf 1. You see that n and 1 there? That is lf 1. Next we have replaceable uncountable infinity, which is lf omega. After that we have replaceable inaccessible infinity, which is epsilon null. Is that e right there? Next we have indescribable infinity, which is Cantor's ordinal. Next, we have impredicative infinity, which is the Pfefferman-Schutz's ordinal. Finally, we have the absolute infinity. So here are some more pictures. So this is actually impredicative infinity, and this is absolute infinity. And thank you everyone. Subscribe to see more epic videos. So hit the like button, share with your friends, and never forget to subscribe. Bye.